You are all welcome to today's presentation. I am your host, Franklin Luando, the lead tutor, Chief Executive Officer, and the pioneer of FCO Accountants Tuition Center. Before I start presenting, I just want to encourage you to ask questions relating to today's question in the chat box. And also, I want to encourage you to make comments in the comment section about the quality of today's video. Also to state whether it is helpful or the comments that will be asked will be used to improve the delivery of the lectures, and all the questions that will be asked depending on the availability of time, they will be attended to. For our new subscribers, do not forget to hit the notification button so that you are able to receive the latest videos every time when they are available. Now, in today's video, we are looking at setting up the price that will maximize the profit. Now, setting up the selling price is very important for an organization. One, in order to be competitive. Two, in order to be profitable. If the price set is wrong, it will have adverse consequences on the organizations as well as on its profitability. So we are going to use the demand function in order to determine the maximum price and also the maximum output that will be produced in order to maximize the profits. So the demand function formula is, price is equal to A minus BX, where A is the price at which demand will be nil. B is the slope. B is the slope, which is calculated as follows. B is the slope, which will be calculated as follows: change in price. Change in price over change in quantity. X is the quantity. X is the quantity when price is P. I want you to make sure that you understand. We are going to answer this question together. And the first step is to calculate B. So we already have the formula here. So the first step is to calculate B. So we have the question here. The total fixed cost per annum for a company that makes one product, $100,000, and a variable cost of $64 is incurred for each additional unit produced. So the variable cost is also referred to as marginal cost. And sold over the very large range of outputs, the current selling price for the product is $160. At this price, the quantity of 2,000 are demanded per annum. It is estimated that for each successive increase in price of $5, annual demand will be reduced by 50 units. Alternatively, for each $5 reduction in price, demand will increase by 50 units. So the dollar is not supposed to be there. Calculate the optimum output and price, assuming that if prices are set within each $5 range, there will be a proportionate change in demand. Calculate the maximum profit. So here, calculate optimum output and price. So you have to follow the steps. Step 1B, change in price here is 5. Change is $5. Change in demand is 50. So there is 0.1. Number 2 is to calculate A, where the demand at that price will be nil. P, we already have the price, which is 160. Minus B, we already have B, 0.1. When the price is $160, the demand will be 2,000. The demand will be 2,000. The demand will be 2,000, multiplied by 2,000, minus A. So there it will be 160. There, A minus 200. Minus A. So here, this is minus 200. So when it goes that side, it will be 160 plus 200 is equal to A. So A is equal to 360. Is that okay now? Are we together? So we know A. So now number 3 is to calculate the maximum output. Optimum output here is where the marginal revenue is equal to MC, marginal cost. So MA here is equal to the formula, first the formula there. Here it will be, when we put in the formula there, it will, here we already have 360 minus 0.1 X. So that is the formula. So now marginal revenue is equal to, you multiply by 2 there. That will be equal, so it will be 360 multiplied by 2 there, it will be 0.2x, which should be equal to MC. The MC, the variable cost there is 64. So we can have this 360. This one jumps the equal sign, becomes minus 64. And this one goes to the other side, becomes 0.2x. So there we have 360 less 64, 296. So 0.2 is equal to x. And this one will give us as divide by 0.2. This will be x is equal to 1480. So now this is the maximum output. So now what will be the maximum selling price? We go to the original, this one. The price will be 360 minus 0.1 x. The x we've already found, 1480. So 360, 0.1 multiplied by 1480 will be 360 minus 148. So the selling price there to maximize profits will be 212. Are we together there? So now the maximum profit will be total contribution minus the fixed cost. So we can use this part. Contribution will be 12 minus 64. Because contribution is equal to selling price minus the variable cost. So this will be 148. That's contribution. Total contribution will be 108 multiplied by 1480. The 148 multiplied by the output, 219, 040, less total fixed cost. Total fixed cost will be 100 we are given. Maximum profit will be 19040. That is a profit from this question. Okay, so we have answered this question, proper part A and B. This video is relevant to students studying SCCA performance measurement and students studying CA 2.2, that is management accounting. Also, those studying CMAP P1, it will be very helpful. And those doing J9 and Zika management accounting, this video will be very helpful for them. Please, for the new subscribers, again, do not forget to hit the notification button. And again, we say thank you for your support, both the new subscribers and the old subscribers. Continue watching these videos. God bless you. Thank you.